Hello, honors pre-calc students. So every day, please spend 10 minutes on this site so that you get very, very comfortable and adept at the unit circle. So you want to be accurate and fast. You want to be able to fill this thing out in under 3 minutes. And so let me just demonstrate. So the website for this is found underneath the modules. It's the first link mentioned in that unit circle module. So you press start game. It's asking which one of these blue dots corresponds to this. This is, you see this comma here, so it's an ordered pair, and negative, negative. So it's asking where are all the ordered pairs, where x is negative and y is negative. That's quadrant 3, isn't it? So that would be this. These blue dots are for radians. These blue dots are for ordered pairs. This blue dot right here is for the quadrant 3. For all ordered pairs in here are negative, negative. This next one is negatives, comma, positive. So what quadrant has negative x values and positive y values? That would be quadrant 2. Now, this is another ordered pair, 3 in a row for a comma, but a very specific ordered pair. Negative 1/2, so to the left a half, and then down, rad 3 over 2. And this needs to be, this is a mistake. It should be rad 3 over 2. The way it's written here, it looks like it's rad 3 over rad 2, which is not correct. It is rad 3 over 2. So you're going to have to ignore the radical reaching down over here. Nevertheless, negative 1/2 to the left a half, down rad 3 over 2 is this ordered pair. So that means the cosine of 240 degrees is negative a half. That's the...
This is just a test. Thank you.
All right, so they were testing. So the cosine is the x value. So the cosine of 240 degrees is negative 1/2. The sine of 240 degrees is negative rad 3 over 2. Cosine is x, sine is y. Okay, now 5 pi over 3, no comma, so it's not an ordered pair. It is a angle. Where is 5 pi over 3?
Please excuse the interruption. We're just testing the all-call system. Again, this is just a test. Thank you.
Pi over 3, pi radians is 180 degrees. So what is pi over 3? Well, if pi over 3 must be 180 degrees over 3. 180 degrees over 3 is 60, because 180 divided by 3 is 60. But this is asking for 5 pi over 3s. So 5 60s. That's 5 times 60, which is 300. So 5 pi over 3 is coterm. It's the same angle as 300 degrees. But you should think of it as 5 groups of pi over 3. So, or 5/3 of a pi. So 1 2/3 of a pi. 1 whole pi will get you right here. And then another 2/3 of a pi gets you right there. And then there's another ordered pair.
Test, testing the call button. Again, this is just a test. Thank you.
Okay, I hope they pass this test. Oh, positive rad 3 over 2, negative a half. So to the right, rad 3 over 2 down here. And I got flustered by that little announcement. And you keep on going on and on and on until you can do at least 90%, hopefully 100% in under 3 minutes. All right. And then
testing, 1 2 3, testing, 1 2 3.
So these are the quadrants of the quadrant 1, and it goes counterclockwise, 1 2 3 4. And this is our unit circle. So we're gonna play a little game. What quadrant am I thinking of? Which quadrant, 1 2 3 or 4, are these two true statements? The sine is less than 0 and the cosine is greater than 0. Which one? Well, the sine is y. So if the y value is less than 0, then you're in quadrants 3 or 4. And the cosine is greater than 0, so that means x is greater than 0. Well, if x is greater than 0, then you're over here, 1 or 4. And so it must be quadrant 4. It is the one that has, where the sine is negative, the y values are negative down here, but also the x values are positive. What about this, where sine is positive and cosine is positive? What quadrant am I in? Well, if sine is positive, you're in the top two. If cosine's positive, you're in the right two. Remember, sine is y and cosine is x. So that brings you into quadrant 1. What quadrant are you in if the y is positive and the tangent is negative? So if the sine is positive, you're in 1 or 2. That's the y value. Tangent being negative, tangent is y divided by x. And if you're dividing two numbers and the result is a negative number, then one of those is positive and one of those is negative. We already know that sine is positive. So the fact that tangent is negative must mean that x is negative. So y is positive, x is negative. That is quadrant 2. The secant is greater than 0. Oy, oy, oy. Secant is cosine flipped over. So that means cosine is also positive. If secant is positive, then cosine is positive. And if cosine is positive, we're looking at quadrants 1 or 4 because that's where the x value is positive. Cosecant is sine flipped over, the reciprocal of sine. And if cosecant is negative, then sine is negative, and you again are in quadrant 4. All right, the cotangent is positive, and the cosine equals this. All right, well, if the cosine equals negative 0.8177, then that is somewhere around here somewhere. Because remember, cosine is x, and the smallest cosine could ever be is negative 1. This is saying that the angle has a cosine of negative 0.8177. So it's either this angle or this bigger angle. Both of those angles have the same cosine. So it's either in quadrant 2 or quadrant 3. And cotangent is positive. Well, if cotangent is positive, then so is tangent. And tangent is positive in quadrant 3. Because remember, tangent is y divided by x. And in quadrant 3, everything is negative, the x's and the y's. So if you divide two negatives, you end up getting a positive. All right, last slide. This one you really please follow along by taking down notes. So we've got this point, negative 913, which is in quadrant 2. So right away, if knowing that it's in quadrant 2, the cosine is going to be negative because we had to go to the left. And it's up, right? The y values are positive, so the sine value is going to be positive. So we're going to let this point be on the terminal side of theta. Find all the 6 trig functions of theta. So what that means is after you plot the point, you can think of a reference or an angle. Theta, that's theta. That's this theta. That's the theta. We want to find the sine of this, the cosine of this, the tangent of this, the cosecant, the secant, and the cotangent. All 6 of this. So how do I do that? Well, first of all, realize the unit circle, we're way past the unit circle. The unit circle is a tiny circle with a radius of 1, but we can still use those ideas to solve this problem. And we're actually going to create a right triangle, which is a common theme in this class, a right triangle. And this angle, this little guy, trying very hard to write theta prime. Theta prime, this is called a reference angle. A reference angle is an acute angle, so between 0 and 90 degrees, and it has the two sides are the terminal side of an angle and the x-axis. So it's nestled next to the x-axis. And the point of a reference angle, and this red thing is called a reference triangle, the whole point is to make your job easier. Because I want to find out what the cosine of theta is. And without I don't know what theta is. I don't know what it is. But I know these 2 points. Well, I can create this reference triangle, and that will help me. So my x value is negative 9. I had to go to the left 9. And the y value is positive 13. I had to go up 13. But we have a huge advantage that it's a right triangle. I can find the hypotenuse of this right triangle by, what's it called? By Pythagorean theorem. So I can do -9 squared plus 13 squared equals the hypotenuse squared. Why don't you please do that while I'm doing it? Okay, so that's 81 plus 169, and that is 250. So 250 is the hypotenuse squared. So the hypotenuse, which is, it's given a name r. In trigonometry, we call this r for kind of like the radius of a big circle. So the hypotenuse, which we're going to call r, is the square root of 250. The square root of 250. But that equals, doesn't the square root of 250 equal the square root of 25 times the square root of 10? Oops. It most certainly does. And so that will simplify to 5 rad 10. And that's what you need to be able to find. So the hypotenuse of this reference triangle is 5 rad 10. And now realize you've got a right triangle, so we can do right triangle trigonometry. We could do that. That's SOHCAHTOA. Cosine. So the cosine of this angle is going to be the cosine of the reference angle, which is, cosine is adjacent over hypotenuse. So -9 divided by the hypotenuse. -9 divided by 5 rad 10. That is the cosine of this angle. And you have to rationalize the denominator. So you multiply both sides by rad 10, and you get -9 rad 10 over 5 times rad 100, which is 5 times 10, which is 50. So this is your goal. The cosine of theta, the green theta, the big one, is -9 rad 10 over 50. And remember, cosine is defined as the x value on the unit circle. This is, if we were inside the unit circle, this would be the x value. You see how it's less than, it's bigger than -1. Cosine will always produce a number between -1 and +1. And so this number is a cosine value, and so it's between -1 and 1. The sine is opposite over hypotenuse. So the opposite of this angle, which is 13, divided by the hypotenuse. So 13 over 5 rad 10. Rationalize the denominator, and you get 13 rad 10 over 50. Tangent is opposite over adjacent. So the opposite of this, which is 13, and the adjacent of this angle is -9. So it's 13 divided by -9, which is -13/9. Incidentally, remember tangent on the unit circle is the y value divided by the x value. Same thing here. This is the y value, this is the x value, and when you divide them, you get -13/9. The other 6 are just the reciprocals of these. Let's start with tangent. The reciprocal of -13/9 is -9/13. That's the cotangent. The cosecant is the reciprocal of sine. So I need to, all three of these fractions are equal to each other. So I need to pick and choose. I need to make a smart choice here. I hope you see that we should pick this first one, because if I reciprocate this, the radical 10 goes in the numerator, and I don't have to rationalize the denominator or anything. This is totally done. And then for cosine, the reciprocal of cosine is secant, and if I flip this, I get -5 rad 10 over 9. A couple of do's and don'ts. When you're writing these functions, any one of these 6, they are functions, so they need a domain. Remember when we studied logs, this would make no sense at all. Natural log equals 9, that doesn't make any sense. The natural log of something equals 9, not just the natural log equals 9. Natural log is a function. So cosine is a function. You need a domain, which is an angle. The cosine of theta equals 1/2. Don't write this. I don't know if you're being lazy or if you truly don't understand. In either case, you're not going to be happy with your grade. Cosine equals 12. This is not a mathematical statement. Cosine is a function. You need a domain and a range if you want to write an equation. So the cosine of theta, an angle, equals some value. Also, I see students do this. They don't write an equal sign for some reason. They just write a dash or an arrow. Don't do that. Just write an equation with the domain and the range.